Welcome students. In this video we shall be learning about the lipoproteins. So it is an important topic from your examination point of view. Now let us understand what is lipoprotein. A lipoprotein are the molecular complexes that consist of lipid and proteins. So I think from the name it is clear that these are containing lipids and proteins. They function as transport vehicles for lipids in blood plasma. They help to deliver the lipid components. So they act as a transport vehicle for transport of cholesterol. These are just the examples for transfer of cholesterol, triacylglycerols or tags. We all know that these are also known as tags or triglycerides into the blood plasma. So now let us first understand the general structure for lipoproteins. The diagram here you see represents the general structure for lipoproteins. It consists of phospholipids. Just see here, these compounds are phospholipids. Then comes the cholesterol esters, then the triacylglycerols constituting free cholesterol, monolayer of amphipathic lipids, core of non-polar lipids, integral lipoproteins and peripheral lipoproteins. So a lipoprotein basically consists of a neutral lipid core. Number one, it consists of a neutral lipid core. Now see here in the diagram, here I am representing this here, a neutral lipid core. This is our neutral lipid core with triacylglycerol and cholesterol ester. So in the neutral lipid core, there will be the cholesterol esters and triacylglycerol. So these orange colored compounds are cholesterol esters and triacylglycerols, which are surrounded by a coat shell of phospholipids. So an outer core that will be containing the phospholipids. See here, phospholipids on the outer core, then the cholesterol, the free cholesterol here mentioned, and then comes the peripheral and integral lipoproteins. So this outer protein part is known as peripheral apoprotein, whereas this embedded protein here is known as integral apoprotein. This is embedded into the monolayer of amphipathic lipids. I had already mentioned here. So due to this, the lipoprotein is soluble in aqueous solution due to the polar portions of amphiphilic phospholipids which are exposed to the outer side. See these purple dots, these are polar ends of lipids. So this makes it soluble in aqueous solution. So now let us once again construct a simple structure for lipoproteins. So as you all know, the outer shell or the coat, now let us first make an outer shell or the coat. So this is the outer shell or coat. It will be constituting the apoproteins. Now first let us construct the structure for apoproteins. These are apoproteins. Then it will be constituting along with the apoproteins the phospholipids. So the hydrophilic ends will be outer side. So these are phospholipids. Now, along with the phospholipids, there are cholesterol molecules that are embedded into this. So, it will be constituting the cholesterol molecules that are embedded in the outer shell. So, these are cholesterol molecules. Now comes the turn for the internal neutral core. Now, this is the non-polar neutral core that will be constituting or consisting of cholesterol esters and triacyl glycerols. So, these are all triacyl glycerols that are present in the neutral core. I am simply writing them as tags, and along with the tags there will be present cholesterol esters. So, the esters of cholesterol will be present here. These are cholesterol esters. So, this is the generalized structure for lipoproteins. Here you can see. Now, we shall be writing the classification of lipoproteins. So, now let us start with the classification of lipoproteins. So, how these lipoproteins are classified? Number 1 are Kylo Microns. So, number 1 will be Kylo Microns. So, what are these Kylo Microns? They are synthesized in the intestine and transport exogenous triacyl glycerol to various tissues. So, these are synthesized in intestine and help to transport the exogenous dietary triacyl glycerols. So, they transport triacyl glycerols. They consist of highest 99% quantity of the lipid and only 1% concentration of protein. So, in terms of composition, they are 99% lipids and only 1% of proteins. So, these are least in density and largest in size among the lipoproteins. Thus, they are having lowest density but a very large molecular size. So, this was all regarding the chylomicrons. Now, the next category is very low density lipoproteins. Now, the second one, these are very low density lipoproteins. Also commonly known as VLDL. So, many of you must be familiar with this term. So, what are these very low density lipoproteins? They are produced in the liver and intestine and are responsible for transport of endogenously synthesized triacyl glycerol. These are produced in liver and intestine and these are responsible for transport of endogenously synthesized triacyl glycerols. So, they help in transport of endogenously synthesized triacylglycerols. The next comes the low density lipoproteins. So the third one is low density lipoproteins. Commonly known as LDL. So they are formed from VLDL. They are synthesized from VLDL molecules. In blood circulation. And they help to transport cholesterol from liver to other tissue. They help to transport cholesterol from liver to body tissues. Now next comes the fourth category, that is high density lipoproteins. These are high density lipoproteins, also known as HDL. They are mostly synthesized in liver, so they are mainly produced in liver. The three different fractions of HDL, so they are fragmented into three different types. These are three different forms: HDL 1, 2 and 3, which can be identified by ultracentrifugation, and HDL particles transport cholesterol from peripheral tissues to liver. So here's the main function of the HDL molecules. They help to transport cholesterol from peripheral tissues to the liver. Thus reverse the cholesterol transport and reduces the levels of cholesterol. So they help to reduce the levels of cholesterol in bloodstream. Thus reducing the risk for atherosclerosis or deposition of cholesterol in arteries. So another fifth type of lipoproteins are free fatty acids. These are free fatty acids. The free fatty acids in the circulation are bound from albumin. These are always albumin bound. And each molecule of albumin can hold about 20 to 30 molecules of free fatty acids. So at least 20 to 30 free fatty acids are bound to albumin. The lipoproteins cannot be separated by electrophoresis. So now I think that classification of lipoproteins is clear to you, and basic structure for lipoproteins also. In our next class, we shall be learning about the concept of metabolism of such lipoproteins, how they are metabolized, and how LDL and VLDL play a role in deposition of cholesterol, plus the role of HDL in reducing the lipidemic amounts in our bloodstream.